1.3 partial fractions. Let's start with a small example. 4 over x minus 3 and 2 over x plus 1. We will simplify this one first. So we know already the methods now. X minus 3, x plus 1. So this is 4 times x plus 1 plus 2 times x minus 3. Now this is going to be 4x plus 4 plus 2x minus 6 over x minus 3 x plus 1. So this is 6x minus 2 over x minus 3 x plus 1. So when we simplify this one, we will get 6 minus 2 x minus 3 and x plus 1. Now we simplify and we get this answer. Partial fractions mean we need to break this major fraction into a small fractions. Partial fractions. So 2 partial fractions. Now we are going to discuss this process. So we know this process, but we don't know this process yet. So under this topic, we are breaking this algebraic fraction into a smaller algebraic fractions. So when we break this kind of fraction into the partial fractions, we want to do few checks. One is the fraction is proper or improper. Proper or improper. Proper fraction, whether it is a proper fraction or improper fraction. If it is a proper fraction, we again divide it into 3. That is 3 types. Denominator with linear fraction. Then second, denominator with repeated factors. The third one is the denominator with irreducible factors. Proper fractions, we need to identify whether fraction is proper fraction or improper fraction. If it is proper fraction, so we have to categorize that fraction into identify whether it is a denominator with a linear fraction, denominator with the repeated fraction, or it is irreducible factors. If it is improper fraction, we want to divide turn into a mixed factor. Mixed factor. And then we have to solve. So proper fraction and improper fraction first of all. What is proper fraction with the numerical? So for example, 3 over 7 is a proper fraction. But 8 over 3 is a 8 over, let's say, 3. 8 over 3 is a improper fraction. What is the meaning of that? When you look at, if it is a proper fraction, denominator is bigger and numerator is smaller. But if it is improper, numerator is smaller, denominator is smaller, the numerator is bigger. Same as 4 over 4, numerator and denominator both same. So they are improper and this is proper. Proper fraction, improper fraction. Now how do you find algebraically proper and improper? It's very simple. When you look at this one, 6x minus 2 and x minus 3 times x plus 1. So 6x minus 2, I'll expand this one, x square minus 3x plus x minus 2x minus 3. Now find the highest power of the numerator and denominator. So we can see the variable power here is 2 and this is 1. So what is the highest power is 2. Now what is the higher powers of numerator? So numerator highest power is 1. Okay, 1 over 2 match with this one now. 1 over 2 is a proper fraction over improper, so it is a proper fraction. Assume this one. Another one we'll discuss actually. 6 over 6x over x minus 3 x square plus 4. When you look at on top, the highest power on numerator is 1. On the denominator, highest power is x cube. Why x cube? When you multiply, you can see that x times x square make x cube. Sorry, x cube is the highest power. So it means 3 is the highest value. So now look at 1 over 3 is proper or improper. Yeah, it is a proper fraction. How about this one? X minus 2 x plus 1 over x square plus 2 times x plus 3. Now when you look at, we can see highest power is x cube and highest power is here x square. So this is 3 over 2. Yes, it is a proper fraction. And I will delete this one now. And I will change this is to x square minus 2. Now what is the highest power? This is x square, this is x cube here, this is x square. Now highest power is 3 and here 2. Now you know that 3 over 2 is with the numerical, it is a improper fraction. So that is a improper fraction. And if I change another one, I'll delete this one. Now what is this one? X square over 2 x square minus 2. So highest power is x square. This is also highest power. So this is 2 over 2. So this is also categorized as what? Improper fraction. So how do we check the proper or improper? We are checking numerator and denominator and the highest power of the denominator and highest power of the numerator we write as a fraction, and we see that it is a, or simply you can tell that if is the numerator power is less than the denominator power, highest power of numerator is less than the denominator highest power, so that is proper fraction. So likewise, you don't need to do anything of this one, right? By observation you can do. So when you look at this one, you can see power is 1 and this is 1 and this is make x square. So this is 1 over 2. Then it is a proper fraction. So you identify as a proper fraction. You don't need to show that. But you have to identify because the methods are different. Now we'll discuss so what are the types? Denominator with linear factors. So this is the denominator with linear factor. Um, so that is, I will rewrite 6 minus 2, x minus 3, x plus 1. Another one, 7x over x plus 1, x minus 8, x plus 100. So denominator with the repeated factors. When I write this one, you may able to identify the difference. So I will write 6 minus 2 and I will write x minus 3 square x plus 1. Now you can see that one factor is repeated and the other one is you can give some other one example 8 x plus 4 times x plus 8 square x minus 2 square, something like that. Two repeated factors. So the other one is 6x minus 2. You may get x minus 3 and x square plus 2. Irreducible. You can't reduce any more of this factor. So this form of factor. So the square is inside the bracket. Now the power is outside. So this square is inside basically. Another one, 6x minus 3 over x cube minus 4 times x plus 1. Irreducible. You can't reduce anymore. So in our book we don't have this one, but I will just give one example. So we have to deal with those two. We'll discuss now how we are going to deal this one. Yes, this is very easy, everything. Now if we have linear factors, you have to simply write a over x minus 3 plus b over x plus 1. If we have 3, another one, c over x plus whatever it is. So for example, 6x minus 2, x plus 1, okay, I'll write 5x minus 3, x plus 1, x minus 4, x plus 7, another one you have. Then you have to introduce a over x plus 1, then b over x minus 4, and c over x plus 7. So that's all. We have to introduce one constant for each factor. So if there is a repeated root, how do we write the partial fraction? So we are writing a over x minus 3. One quotation for him, x minus 3. The other constant for the square part of it, x minus 3 square. So like we are climbing a step like 1, 2. So this is for A, this is for B. Right? and then c over x plus 1. What will happen? 6x minus 2, I have x minus 3 cube times x plus 1. 1 square, I'll put 1 square. Then how do you factorize? So we need 5 constant now. A over x minus 3. Then now this is 1, 2, 3. B over x minus 3 square and c over x minus 3 cube, and then the other one deal. So d over x plus 1. So it has only 2 steps. And e over x plus 1 square. That's all basically. If it is irreducible factor, we are writing a over x minus 3 because that is linear as usual. Then we write x square 2. If this is x square, we want to start with 1 less than with the bx and plus c. Assume this is x cube. Then 1 less than x cube is x square. X square. So then bx square plus then cx plus d. So 2, 1. Actually, this is x0. X0 is 1. So 2, 1, 0. 0 is a constant. Descending order we want to write. If it is 4, then 1 less than 4 is 3. X cube. So a is here, then bx cube, cx square, dx plus e. So that's how we do. I explain this to complete the session. We work with next two on this one, and we are not going to discuss this one. So we'll discuss proper, the linear factor and this one, and how to solve and find a and b and c's, and then the improper one after that. We'll discuss example 8, that is 6x minus 2 over x minus 3 x plus 1. So there are two methods. One is substitution, other one is equating coefficients. So we'll work with both ways. Now you know what to do first. So you look at, when you look at, okay, you will see that the highest power is 1 and this is highest power is 2. Okay, this is a proper fraction. So then there is no issue. So, and this is a linear. So we, as usual, we write a over x minus 3 and b over x plus 1. Now we'll simplify because we need to find a and b. So 6x minus 2, x minus 3, x plus 1 equals 0. So I will find the common denominator of this one now. What is the common denominator? We know x minus 3 and x plus 1. And I will multiply this one. This is a times x plus 1 times b times x minus 3. What I did was I simplified this one. We know that 1 over 3 plus 1 over 4. How do we simplify? So 3 times 4. So how many 3's goes to 3 times 4? 4. 4 times 1 is 4. I will write a and b. 4 times a is 4a. How many 4's goes to 3 and 4? 4, 3. 3 times b is 3b, something like that. That's the same calculation I did. But a over 3 and b over 4, you know 12. And you can simply, by looking at, by observation, without thinking, you can write. The same thing I did. Now, you can see that both denominator is same. So we can drop this one and we can write 6 minus 2 equal a times x plus 1 and b times x minus 3. Why we are able to write like this? Because this is same. You can cancel out. What is really happening? You bring x minus 2 here, then it is going up. X minus 2 to x minus 3 cancel out. X plus go up, x plus 1, x plus cancel out. The same thing we can do by like this. Because they are same, we can cancel out. So x over 3 and y over 3. X equal y. So that's why we write. Now, when we come to this level, we are substitution. We can assume x equal 1. So what is the answer? 6 times 6 times 1 is 6. 6 minus 2. And this is x equal 1. Let x equal 1. So 1 plus 1, 2a. This is 1 minus, this is 1 minus 3 minus 2, minus 2b. And let x equal any other number, 2. So 2 times 6, 12 minus 2, okay, 12 minus 2. So 6 minus 2 is 4, I'll write like this. Then 12 minus 2 is 10. And then 2 plus 1, 3. This is 3a. And 2 minus 3 minus 1, minus 1b, which is minus b. Now this is two equation you have to solve simultaneously and find a and b. And you can substitute here. Now I have this x equal 1 and x equal 2 I selected randomly, and it a waste of time. But if you select the numbers smartly, you can save a lot of time. For example, if I select x equal minus 1, so this is going to be minus 1, minus 6, minus 2, minus 8. And what is minus 1 plus 1? 0. 0 times a is 0. It is vanish. This is going to be minus 1, minus 3, minus 4b. So this is going to be minus 4b. So we can b is what now? 2 straight. We found why. We took a smart decision. Because when I look at this one, I can see if I put minus 1, then I can vanish a. Now, the same way you can do that. X equal 3. When you put x equal 3, 3 minus 3 is vanish. 3 minus 3 is 0, b is vanish. So then 6 times 3, 12, 18 minus 2, 14 equal, this is going to be 3 plus 1. So this is 16 actually. And this is going to be when x equal 3, 3 plus 1, 4, 4a. 4a plus 0. So a equal 4. Now we can finish our answer. We know now what is the values. 6x minus 2, x minus 3 times x plus 1 equal a is 4. We found out. Over x minus 3. What is b value now? 2. Plus 2 over x plus 1. So that is substitution method. So you substitute some values. Now we'll find this A and B using equating the coefficients. First of all, find, so this is 6x minus 2. Now what is this one? I'll expand ax plus a plus bx minus 3b. So 6x minus 2. Now I'll bring these two together. Can I write a plus bx because I put those two together? And this is plus a constant. Plus a and minus 3b. Now equation the coefficients. So we can see that coefficient of x. When we do vector calculation, 3x plus 4, 3x xi plus 4j equal 3I plus 9j. Now what is x? X equal 3 and 4. Okay, this is y. Y equal 9. So what did you do? We equate the coefficient of I and j. So what is the coefficient of x left side? So this is the coefficient of x. This is 6. What is the coefficient of x in right side? A plus b. So 6 equal a plus b. And then the coefficient of x0, or simply write constant. Here the constant is minus 2. What is here? A minus 3b. So this is 1 and this is 2. So 6 equal a plus b and minus 2 equal a minus 3b. So I took this is 1 and 2. Now solve those two together and get the find a and b. So we have to come up to here. When we come up to here, we have to select the two option, substitution or equation. Sometimes it could be mixture of this, combination of this. We will discuss that when the question is complex and we need to save the time, and then we have to reduce the number of calculations, and I will show you we have that kind of examples. How do we use both two together? So now this is finally we did equating the coefficient. We simplify and we equate coefficient of x. This is 6 and a plus b, and we equate the constant minus 2a minus 3b, two equations solve, and then we will get a equal 4 and b equal 2 when we solve. We'll discuss exercise 1d and then 1e.